So let's talk about what a derivative is by using this thing we call the difference quotient, right? So difference means subtraction and quotient means division. Basically, we're looking at this slope formula. Okay, y2 minus y1 over x2 minus x1. Okay, derivative means slope. That's what I need you to associate all the time. Derivative means slope. So let's look at the graph. Let's just do a nice quadratic graph. Quadratics are nice graphs. So here's a random, non-specific quadratic graph. Okay, so we're going to find the slope of a line, right? So all about slopes. So we're going to pick two values, right? We're going to call one of them x. So here's our x value. So this is the y coordinate, right? This is f of x. Okay, so we have that right there. And then we're going to come some random distance away, and we're going to call this distance h. Okay, so we're going over here to another point that is h units away, right? So we're going h units away. So this is the coordinate x plus h, right? If we move h units away from somewhere, we are adding that length in there. Okay, so we're going to have this value right here, which is f of x plus h, right? So this is a y value, and this is a y value. And then we have our two x values. So what we can do is, of course, draw a line that connects these 2 points. Okay, and this line is called a secant line because we're using 2 points on our graph to draw us a line, right? This is the average rate of change of our function. Okay, so what we're doing is we're finding, right, so this is called a secant line. It has 2 points of intersection, thus called a secant. So what we're going to do here is we're going to shrink down this h length. We're going to make it smaller and smaller and smaller, right? We're going to make this smaller and smaller and smaller and smaller. So our coordinates are going to come in closer and closer and closer and closer to our actual value of x. Okay, and what that's going to do is it's going to bring our secant line in, right, more and more and more and more until we are close enough that it's going to become a tangent line. So a tangent line is one that has only 1 point of contact on your graph, right? 1 point of contact on a tangent line. And that's going to be exactly there at your x value. So we're going to make h be infinitesimally small, closer and closer and closer, so that our secant line is basically a tangent line. Okay, so we're using this slope equation, right? This is your y2 value, that's y2, and this is y1 over x2 minus x1, right? This is just a slope equation where we have some coordinates. Remember, f of something is a y value. So we have y2 minus y1 over x2 minus x1. Right? So this represents the slope of your line. Right? That's what it's going to simplify to. So x minus x is, of course, 0. So we get this. This is described as your difference quotient. The limit as h approaches 0. So we're getting smaller and smaller and smaller intervals, right? Getting closer and closer and closer to our actual value of x. Okay, so let's do that with this nice quadratic equation here, negative x squared minus 4x plus 1. Okay, and this is the long way of finding out what our equation, so we're going to find the equation to generate or to calculate the slope of the tangent line. Okay, so we're going to take this and use it to find the equation of the slope of the tangent line at any value of x. Okay, that's what the derivative is all about. It's an equation that we're going to use to calculate the slope of the tangent line at that given x value. So let's do it. This is finding the derivative the long way. Okay, there are lots of rules that we're going to learn soon, but this is the long way. So first, we're going to take our x plus h, and you're going to plug it into both of the x's in your original equation here. Okay, so that's the negative of x plus h squared minus 4 times x plus h plus 1. Okay, so that is the f of x plus h part. It means replace x in each of your equations with x plus h. Okay, and then minus off the original equation. So minus negative x squared minus 4x plus 1. Okay, and then divide all of that by h and take the limit as h goes to 0. So we're going to get smaller and smaller and smaller values. So the limit as h goes to 0. Right, so there, all we've done is we've replaced x in your equation with a plus x plus h, those two places, and then we've subtracted off the original. So now we're going to do the algebra. Right, this is the arduous part of calculus, is doing all the algebra. So we'll do it one step at a time, right? This is the limit as h goes to 0. So we'll talk about the blue stuff first. We're going to square x plus h. Okay, first we're going to square x plus h. So the negative of x squared plus 2xh plus h squared. Okay, and now we're going to distribute our negative 4 into here. So minus 4x minus 4h, and then plus 1. Right, we don't have to do anything with the plus 1. So that is the blue stuff simplified. Right, all I've done is I've simplified my blue stuff. Same thing with my red. We're going to change all the signs of all of this stuff inside here. So this is now a plus x squared, a plus 4x, and a minus 1. All divided by h. Okay. So let's see, where else we go? Equals. Let's simplify the blue some more. So the limit as h goes to 0 of, let's see, this is going to be negative x squared minus 2xh minus h squared. And then we have a minus 4x and a minus 4h, a plus 1. And then we have a plus x squared, a plus 4x, and a plus 1. Okay, that's all the stuff we have in our numerator, all divided by h. Now, if we did this correctly, right, if we did our algebra correctly, then we should be able to cancel out a bunch of stuff. Like this positive x squared subtracts with this negative x squared, right? That's 0. This minus 4x and this plus 4x add together to give us 0. This 1 over here has the wrong sign, doesn't it? That's not a plus 1, that's a minus 1. Because these ones should also be gone. This plus 1 and this minus 1. And the only thing we should have left are all h terms. So we have a minus 2xh, we have a minus h squared, and we have a minus 4h, all divided by h. Okay, so if you do your algebra correctly, the only things that are left should be your h terms. Okay? And now since all of these terms, every one in the numerator and the one in the denominator have an h, I can cross off one h from every single term. Okay, we can common factor, right? That's actually what we're doing, is we're pulling out a common factor of h, and we're canceling this common factor h with the one on the, that's what we're doing mathematically. Okay, so now when we plug in 0, right, we get this equation, minus 2x minus 4. So this is the derivative. This is the equation that we're going to use to calculate the slope of the tangent line for any x value. Okay, so we have just found the derivative. In fact, derivative notation, we're going to use this so much, is called f prime, the first derivative. So we put a tick mark up there, f prime of x, right? Formally speaking, f prime of x. F prime stands for the derivative, or in this case, the first derivative, because we can take many, many derivatives. But the first one is f prime. Okay? That's some good work, y'all. That's a lot of math. That's a lot of algebra going in here. Okay, your results of the previous limit is defined to be the derivative, and here's your derivative function. Okay, so here we have, let's see, this was our derivative, right, negative 2x minus 4. So if we're looking for an x value of negative 4, that is the slope of the tangent line to the graph when x equals negative 4. So negative 4 is here, right? So we can draw, I don't know, the tangent line might look like this, right? So this would be the tangent line to the graph at x equals negative 4. So what is the slope of that line, right? That's what they're trying to ask us. So we plug it into our equation for the derivative, aka slope. Negative 2 times negative 4 minus 4, which is 8 minus 4, so 4. So looking at the graph that I drew, does that look like it could have a slope of positive 4? Right, 4 units up, 1 unit over. Yeah, I think that's definitely reasonable. So at negative 4, this graph has a tangent line slope of positive 4. Okay, how about at negative 2? What do you think the slope of the tangent line is going to be at negative 2? Well, let's plug it in. What's negative 2 times negative 2 minus 4 is 4 minus 4, which is 0. Okay, we're going to find that whenever our graph has a maximum value or a minimum, right, then the tangent line is horizontal. Okay, we have a 0 slope right there. That's an important concept. Okay, and then at negative 1, what do you think the slope's going to be here at negative 1? Right, the tangent line approximation. There we go. So negative 2 times negative 1 minus 4 is approximately negative 2. Okay, so we can take this derivative and use the derivative in order to write the equations of tangent lines. Right, that's a pretty big idea in calculus, is what is the equation of the tangent line to a graph at any given value of x. So formally speaking, okay, the definition of the derivative is that limit, so let's start with here, okay, f prime, right, the derivative f prime is defined as being the limit as h goes to 0 of our difference quotient, which is your y2 value, which is f of x plus h, right, has been moved over a little bit, minus your y1 value, which is your original function, all over h, right, as the limit as h goes to 0. So that is our formal definition of a derivative. The limit as h goes to 0 of this f of x plus h minus f of x all over h. Okay, and of course what it means graphically is this right here. It's the equation that we use to calculate the slope of the tangent line to the graph for any value of x. So that's the most important thing. This whole entire setup here is used to find the equation. We're finding an equation that we're going to use to calculate the slope of the tangent line at any point x. Okay, so when you hear derivative, think slope of the tangent line. And when you hear slope of the tangent line, think derivative. Okay, those two are interchangeable and synonymous. And if you can remember that, then all these things about derivatives will be pretty easy. Conceptually, I mean, yes, the actual math can be quite tedious, but the conception is that we are figuring out what the equation of the slope of the tangent line is anytime you find a derivative. Okay, so I hope that helps. And now you have a better understanding of what a derivative is.